Hello and welcome back to my Java tutorial series. As you can see, our product from the last episode, which I'm actually just going to snatch real quick. And then we'll create our new Java project for today's episode, which is episode 18. And today we'll be going over the advanced portion of I/O streams. So, in the last episode, we went over strictly unbuffered streams, which means for every single time you call read, it's going to call the native operating system to read that one thing. Now, that means if it's slow. So, like every single character in our previous poem we were copying, it would call the native operating system to read and then write, which was very cumbersome on the system. Obviously, it was a very small program, and you couldn't really see it. But when you're dealing with either large files, well, yeah, either large things you're reading and writing or other things, it's a lot slower than what we're about to go over, which are buffered streams. Now, I did grab the previous episode's work for a reason, which I hope that, yeah, that auto-imported. I'm just going to change this to an asterisk so we don't have to deal with importing the other things you'll have to do. But basically, we're just going to say, instead of file reader, this is going to be buffered reader. And this will be buffered writer. And what we do with this is basically, we're still going to be using the exact same reader and writer, but we're going to encase them and buffer them. Of course, this is the writer. So that was pretty easy. So basically what the buffer reader does is that when you continue to read, it's going to continue to pull, it's going to continue to just build up its buffer. And when the buffer of all the bytes you're requesting to read reaches a certain number, then it sends a whole bulk command to the OS in order to read all those things at once, instead of doing a separate command for every character. Now we're just going to make the same folder as before. Text, and we're going to put some untitled text files in there. I mean, we're going to put more in this episode. This time, we're going to just deal with how about the second stanza of the Raven. So we're going to do char in, because this, we're going to deal with a lot of different streams this episode, and this is just for our buffered character stream. So again, we're also going to add another, oh yeah, there it is. This is going to be char out, character out. There. So now, we do it, it's reading, and we need to just change this real quick. It's reading from char in, and it's writing to char out. So now this is just a buffered character stream. Now, of course, in the last episode we also had byte streams. The only other difference is that you would have a buffered input stream. And so yeah, it's just a buffered input stream, and you'd be doing the exact same thing as we did with these. You would just do a buffered input stream, new file input stream, and the file name. It's that simple. But obviously we're not going to be doing anything with it. And maybe you'd want to delete that so we don't have to do all the other complications, with closing it and everything. So basically, this will just be a much faster way to do the exact same thing, our character thing. And since it's a character stream as opposed to a byte stream, it is ready for internationalization. Let's just run this real quick. And as you can see in char out, exact same thing as what we wanted it to do. So that's the buffered stream. Now there's two other streams that, of course, we would like that are invaluable, really. So what we're gonna do avoid we're just gonna put this all over here. Of course, we're just copying and pasting because with all this, with IO streams, basically the format is exactly the same for everything. So, you know, it's really easy to use. Now, the next thing we're going to be doing are data streams. Data streams are basically IO streams, but instead of dealing with characters or bytes at a time, it deals with primitive data types or strings, which is a lot better, which means you can like store all these primitive data types and strings outside of the program in another file, which is, you know, how you would make save data and such. So when you close down the program, all those variables will still be available for you to load later on. So and then there's also another thing that's an object stream, which does the exact same thing with objects instead of primitive data types. But you can store strings in both. Really depends on what you're doing. So I'm just going to make two things. Private static void save data. And then a private static void load data. Because obviously you wouldn't but just be saving data and loading it in the exact same swoop, or just copying over these the data into something else. You'd be, you know, saving it, and then at a later date you'll be loading it. So what we're gonna do is, I mean, it's pretty intuitive. It's a data input stream, which actually I probably just wanna. We're just gonna copy this over to each one of these, but we're gonna eliminate whichever one it doesn't want. Like, we don't want to be able to save when we're loading. So we'll just use the file stream here. We don't need file out at all. That's not what we'll be doing. Yeah, we don't need file out at all. Which means we can really just compact the code a lot. And we'll get there when we get there. But, you know, obviously we're going to save before we load. So we need the... we need a data output stream. So we don't need the file in, but we do need a data output stream. Obviously, this isn't going, well, not obviously, but this isn't going to be encasing like a file reader or anything. Well, actually, it's going to be quite a bit more intrinsic, a bit more inceptive. This is going to suffer a buffered output stream. I believe. Oh yeah, file. There. So first you have a file input stream, which obviously is an unbuffered byte stream. Then you buffer it into a buffered byte stream, and then you make it specially formatted so you can store data in the way that Java likes to store data. Now before we go any farther, we're going to go back into text and just make a couple new untitled text files. This one will obviously, you know, be stored in texts, and we're going to call it data.save. And it doesn't have anything into it, and it won't have anything in it until we obviously save some data. Oh, I didn't want to open it with that. Please ignore the text edit behind the curtain. or we want to open this with the text editor. There. So now we go to text, and this time it's going to be data.save that we're dealing with. So what we're actually going to be doing is we need some variables. So I'll just go over here and make some public static variables. And these need to be primitive data types or strings. So let's just say I want to load integer 14. Oh, well, I forgot. It needs a name. Equals, I don't know, 2.71951. And then we'll do a public static string hello. And yeah, I think that's enough for now, I'm sure. Get rid of that. And what we're going to do is we're going to do file out dot write. First thing we're going to do is write an integer. We're going to write int 1, and file out dot write double 1, and then we're going to do file out dot write. You should be like, where is it? Oh, you can write characters, yeah. So we're going to be storing hello as a string. So then, of course, after that, you close it later, which of course we're handling, or else we would be bad. Because it's bad to not close your streams. It's very immature to say. So now, oh wait. Oh, here we go. There. So instead of, we're not going to write it as an array of characters, we're going to write UTF, which is something text format. Oh, I think it's like unified text format. I'm fairly confident that it's, but yeah, UTF-8, and there's like UTF-16 and UTF-32, which is the number of bits in it, but it's basically the universal, the widely accepted system of it. So right now we're writing in UTF-H our string hello, which is good. So that means it is ready for internationalization. So we can save that and do stuff, and you know, we pretty much don't care. Which is why we're not saving and loading at the same time. Because, you know, if you don't save and load at the same time, you just don't do it. Again, we're just going to change this. And it in. And of course, we need to encase this in a new data input stream. There. Now that's ready. So what we're going to do here is we're just going to print these out. System.out.println. And we're going to do this for every variable. So we're going to do, hey, integer 1 equals file in dot read integer. Now the point is, you need to, wait, plus, silly me. Now the thing is, with reading, you need to read in the same order you write. Because obviously you can't read a certain thing at once, so it's all order dependent. So that's why we're going to read the integer first, and then we're going to read the double. And then, finally, we're going to be reading the string. Okay. Read UTF. So that's fairly simple. Now, first thing we're going to do, we're going to save data first, because, in a program you save data long before you load it. So we saved it. If you look in data.save, there's this weird stuff. Because, Java uses a certain encoding. The reason why these are in question marks is because normal Eclipse, when you're editing in Eclipse, it normally runs off of just ASCII and not UTF. So these are UTF characters that it's not registering in ASCII. You can change that, but we're not worried about that right now, because it'll still read and write perfectly fine. It's just what you see that's different. But yeah, it encoded, like the integer and stuff in this weird characterization, then it stored the string like this. So now, we already saved data, so, wait a couple hours, I don't know, we close the program, we reopen the program, and when you, like your program might save data when you close it, then when you open it, it loads that data. So now, if we run it, it should read it equals 14, which it does, it equals 111, and it equals hello world, so it's exactly right. So obviously you can see the advantages. Now, obviously you can only store primitive data types, and I believe this episode is probably getting a bit long, which of course I apologize for, but we're going to get into something else that's really useful, which is just storing objects. Which, we're just going to keep it easy, and, we're just going to save, how about a hash map? That sounds nice. We'll just do a public static hash map string, I don't know, let's just do something double. Why not? No one ever does that. Now we just have to import Hashmap real quick, which of course is no problem at all. So what we're gonna be doing for the object streams, again, the format for the streams are, almost always the same. So what we should be able to do is just, we're gonna convert save data into save object. And instead it's going to be an object. And I think we can just do this. Yeah, there we go. We have an object output string. It's pretty dang easy. But with object output stream, you can still write these integers and doubles and everything. So it like extends the other stream. What we want to do here is what we can't do in the other string, and we're going to write object, and we're going to write ArtMap. Now, in order for you to write objects, they have to implement serializable, which is just an interface which we've seen when we've worked with Swing with our default serial UID or whatever. That's part of the interface, and you prefer one of those when you're dealing with actually writing them and stuff. Serializable means you can save it and load it, and you can store it in something like a hash map. So if it's not serializable, you can't store it in a hash map, or else bad things happen. But yeah, that's that. Also, we're gonna be it doesn't matter. So then, of course, that worked. That's really easy. Then, as one could expect, loading is equally as easy. Again, it's just an object input stream as opposed to a data input stream. And instead, what we're going to do this time, we're obviously just writing the map. So what we're going to do map dot put actually no, we're just going to say map equals fileIn.readObject. And of course, when you're dealing with objects, it returns an object, and you're setting it with a map. Now, since this is a pretty simple program, it's easy to keep track of. So we're just going to say, hey, this is a hash map, and you better like it. This is a hash map that stores a string and a string and double, and you better like it. So obviously, it might not like that. Oh yeah, it also needs to be put in a. Oh yeah, we just need to handle a different exception. What was the exception it said? Was it a class not found exception? I believe it was. Yeah, perfectly fine. Of course, that's going to be yellow because, you know, the program's not sure what the hell you're doing. So we're just going to put that in the main method. So yeah, we're saving and loading a map. Go us, we're cool. What we're going to do, system.out.println. We're going to be doing 2 of these. We're going to do, and before this, we're going to do map.put. And we're just going to say pi equals 3.141591 is close enough to what pi is, in my opinion. I don't try to memorize pi. Then we're going to put e. Actually, no, we're just going to be more accurate, and we're going to do math.pi. There. This is going to be math.e. So here, as an example, we're going to say pi equals map.get. And our key will be the string pi. And likewise, we're going to say e equals plus map.get e. So we're just going to be saving the data real quick, which we're saving to the exact same file. So I'm just going to clear this out. There. So now, right now, all we're doing is saving, and it'll also print out what's going on. So hey, that's pi and stuff. So now we're just completely eliminating that. So obviously this it's done. Since our program has just ended, that means it released all of its data. So map is no longer equal to anything. We don't have anything for map. If we look back in data.save, when you're storing stuff that stores other things, you can get pretty fucking crazy. But that stores all the things that were in map. So that means we have this has no idea what's in map. We don't put anything in it except what we load from the file. So just to prove the power of all this input and output. So if we do this, it equals the exact same thing, and we didn't even set that in our program. We saved it in an earlier date in a practically different program, and we load it, which is the magic of, you know, file saving and loading and everything, and especially with object streams. Now again, just, you know, read and write in the same order that you, well, I mean, read in the same order that you wrote, or else it'll get really confusing. But again, this has been episode 18 on advanced data streams. I appreciate you watching. I hope you enjoyed, and I hope you learned something. But I'll see you next episode when we deal with file I/O. And good night, and see you next time.